This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. All right, we're asked to state an identity I can use to find the exact value of cosine of 15 degrees. Now, you could use the difference identity for cosine, or you could use the half angle. For instance, you could do the formula for the cosine of a over 2, right? There is an identity for that because you could think of the cosine of 15 degrees as the cosine of 30 degrees over 2. So that's one you could use, 30 degrees over 2. So you could write this formula down. I find the half angle identities, harder to remember. So a different possibility is to use the difference formula, and that's one I'm going to use. So I'm going to use this formula, a minus b, and the reason I know this is going to work out because I could think of two special angles that have a difference of 15. That could be 60 and 45, or it could be 45 and 30, for instance. So what is the formula? It's the first thing we're asked to do to state the identity. Cosine A, cosine B, plus sine A, sine B. But we want to find the cosine of 15 degrees. So we start off by writing what we're looking for, which is the cosine of 15 degrees, and rewriting it as a difference of two angles. 15 degrees could be written as the difference of, how about I pick 45 and 30 degrees? You might pick something different. So we're plugging in 45 degrees in place of A and 30 degrees in place of B. We have cosine of 40 degrees, cosine of 30 degrees, plus sine of 45 degrees, sine of 30 degrees, and now you do need to know the cosine and the sine for both 30 and 45 degrees. I don't memorize that, I always draw a little picture. So for 45 degrees, I remember this little picture, 1 square roots of 2. And for 30 degrees, I draw this picture, which is square root of 3, 1, and 2, and I look at these to figure it out. Okay, so the cosine of 45 degrees would be 1 over square roots of 2, right, x over r, which I'm going to rationalize the denominator and write that as square root of 2 over 2. The cosine of 30, x over r, is square root of 3 over 2. All right, sine of 45 is also square root of 2 over 2. And the sine of 30, y over r, is 1/2. So I'm just going to simplify each fraction. Square root of 2 times square root of 3, the numerators, is square root of 6 over 4. And square root of 2 times 1 is just square root of 2, and the denominators multiply out to be 4. And I have a common denominator, so I add the numerators. Square root of 6 plus square root of 2 all over the denominator of 4. So that is one way to find the cosine of 15 degrees. You might have used different values, 60 degrees minus 45 degrees or something else, and you might have also done it using a half angle identity, but you should still come up with the same answer, especially if it looks a little bit different. You're not always wrong, because if you plug the values in the calculator and you get the same approximation, there's more than one way of writing square root of 6 plus square root of 2 over 4. All right, next problem. State an identity you can use to find the exact value of sine of 105 degrees. All right, again, you could use a half angle identity. You could do 210 degrees divided by 2 and use that formula. I think it's easier to think of this as the sum of two special angles, so that's the one I'm going to use. And the two special angles would be 60 and 45. So first we're just going to write the formula for the sine of a plus b. Sine a cosine b plus cosine a sine b. This is the formula, or the identity, right, for the sine of a plus b. And we want to find the sine of 105 degrees by writing it as the sum of two special angles. So 60 and 45 degrees are one possibility. There's many ways you could do this problem. So using the formula, it's the sine of 60 times the cosine of 40. So the sine of 60 degrees times the cosine of 45 degrees. I think I said 40. That was just me saying the wrong thing. And the cosine of 60 degrees times the sine of 45 degrees. Alright, so again, I don't usually memorize these. The cosine and sine of 45 degrees, those are pretty easy. That's square root of 2 over 2. But the 60-degree angle, I'm just going to draw a quick picture. 1 square root of 3, 2, right? That's 60 degrees. All right, so the sine I see is 1/2. Cosine of 45 is square root of 2 over 2. Cosine of 60 degrees is square root of 3 over 2. And the sine of 45 degrees is the square root of 2 over 2. And so if I simplify each fraction, square root of 2 over 4 plus square root of 6 over 4. Same denominator, so I just add the numerator, square root of 2 plus square root of 6 over 4. And there's the answer. You might have noticed that the sine of 105 degrees happened to be the same, I think, as the previous problem, right? Square root of 2 plus square root of 6. Here we got square root of 6 plus square root of 2. So the cosine of 15 degrees is positive, and so is the sine of 105 degrees, and it just happens to equal the same thing. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.